Hello, welcome to our third geometry lesson of the year. We're going to jump in. We're going to do section 1-4, means we're in chapter 1, section 4 of that chapter. And I got my lucky tie on today. It's my favorite tie of my collection, so it's bound to be a good lesson. We're going to talk about measuring angles today. You've heard about angles for a long time. Everybody kind of has a general idea what an angle is, but before we talk about angles, we got to talk about the things that make angles, which are called rays. All right, ray is kind of like a part of a line. Some people think of it as like half of a line, though mathematically that's what is half of infinity, so who knows, but it's a part of a line that has one endpoint and extends forever in one direction. Now I'm not talking about Zane and Harry and those guys in one direction. I'm talking about an actual direction. It's just going in one direction, right? It doesn't go forever this way, just one direction. Rays are named by their endpoint first. Now that is a little different from lines and segments and planes. Didn't really matter the order of the points on those. Ray order does matter. You always have to use the end point, the one that has, it doesn't go on forever. You have to use that point first and then go this way. Now again, I have 3 letters. I did that on purpose. You do not need to you never use 3 letters to name a ray. You have to, in this example, you have to use the letter M. You could call this ray MP, or you could call it ray MO. Either one is correct, but not the other way. You can't go backwards on a ray. All right? So, and here's the examples. And again, when you're making this an answer, you can literally, and you'll probably have to use this one a lot, the actual word ray. Ray, then capital M, capital O. You won't probably be able to do this on your Chromebook, but you could, if you're doing paper and pencil, draw a ray MO. But the M in this example would have to be first because that is the end point and it's extending forever that way. Or like I said, you could say MP, ray MP. All right. Before I jump to the next screen, I mentioned in the lesson about points, lines, and planes that there really isn't such thing as a line in the real world because they go forever in both directions. That really doesn't happen. Planes, remember we talked about a sheet of paper that goes forever in all directions. There's really nothing like that in the real world. But I can think of 2 actual examples of rays in the real world. So if you think you know what those are, or you know one real example of a ray in the real world, zip me an email real quick and say, hey, this would be a ray in the real world. And if you're the first one I'll maybe give you a bonus point. Otherwise, we'll move on, and I'll reveal the answer to that at our next lesson. Okay. Opposite rays. Opposite rays, those are collinear rays. It means they're on the same line together, okay? But they share that common endpoint and they extend in opposite directions. If you did have opposite rays, like if I use these two SmartBoard pens as my opposite rays, they have a common endpoint, so I'd put them back to back, and they go this way and the other one goes that way forever. If you put them together, they would form a blank. Who thinks they know what that would be? That's right, a line. If you put rays back to back, they form a line. Good job. Any questions on that? And again, here would be your endpoint. JH would be a ray going off kind of to the left. JK would be a ray going off to the right, and back to back, that creates an actual line, and I've even called it line L over here. I apologize, I'm going to have to recalibrate. I'll try to do it quickly. Okay, and that covers that screen. Any questions so far? If you do, zip me an email. Moving on. An angle. So if you put 2 rays together and their endpoints are at the same spot or a common endpoint, you've created an angle. I'm going to use this symbol for angle because it's just quicker. It's one little character. The word angle is 5 letters long, so I'm going to use this. It looks like an upside down 7. All right. So angles are formed by two rays that have a common endpoint. So here's a ray right here. And then if I put another ray and make their endpoints common, you see I've created now an angle. All right. And angles can be named in 3 ways. So pause this screen if you need to. I'm going to go through the 3 ways. You can, and this is the most common way, number 1. So put a asterisk next to that. This is probably the way we'll use the most. Using the 3 letters with the vertex as the middle letter. The parts of the 2 rays that make the angle, you'll never believe this, but those are called sides. All right, those are the sides of the angle. Where the 2 rays come together, their endpoints, that is called the vertex. We will have a lot of vertexes in geometry. This is our first one. Okay, so the 3-letter way, the most popular way, the way that it will confuse you all a lot, is you can call this angle here, you could call it YXZ, or if you wanted to go the other way, you could go ZXY, but in both cases, the X was the middle letter because that's the vertex. All right, the vertex is always the middle letter. Sometimes, and this is the way we'll probably use the least, but they do it because it sometimes confuses us with other things. If there is a number located in it that does not have a degree symbol, little degree symbol is a little circle or a dot up here. That means that is its name if it does not have that degree symbol next to it. So you could also call this angle, you could call it angle 3, which I've done right here. And then the last way, and this is if there's only one angle in your diagram or whatever you're looking at, you can simply name it by its vertex. And this vertex is X, so if you wanted to, you could call it angle X, but you can only do that if that's the only angle at that vertex. Now some of y'all might be saying, well, how could you have more than one angle at a vertex? Well, if I drew another ray off of here like this, and that would create another angle, now there's 2 angles at this vertex, so you could no longer call either one of them just X. You would have to use a 3-letter name or something else. So that one we don't use very often just because our drawings are going to be more complex as we get further in this lesson. You all are going a little off the bottom of the screen here, so let me back this up so you can see that. Sorry. Okay. Can you see the top of the screen? I think so. Okay. Wow, it's getting cutting close down there at the bottom. All right, moving on. Draw this beautiful picture. This screen is very pretty much easy, and as long as you understand the words interior and exterior. Interior is a fancy word that means inside. Exterior is a fancy word that means outside. And points can have 3 possible relationships with an angle. If you think of an angle as an alligator's mouth, which I know a lot of teachers in the lower grades kind of use that analogy, and it's not a bad analogy. If this is like an alligator's mouth, and the alligator closes his mouth, if you were inside, like points S and R are, you are in the interior. If you would get eaten when he closes his mouth, you're in the interior. If you wouldn't get eaten, like points P and O, they're on the outside, we would say they're in the exterior of the angle. And the last thing is points N, M, and Q. They lie literally on the angle. So they're not inside, they're not outside, they are literally on the angle. N is, you see the dot, M, and Q. So that's your 3 possibilities. You could be inside, outside, or literally on the angle. And again, I'm going to keep moving fast. If you have any questions. Boom! Oh my goodness, we got a skip screen right already. So this is a complex drawing here, some stuff, but apparently it's not important anymore, so we're going to move on. And I'm going to refer to this picture a lot this year. It's a concept that we use over and over again. Now, I haven't taught you anything yet about circles and very little so far about angles, but I think some of you all have some prior knowledge and know some of these questions. First one is, angles are measured in units called blank. Does anybody know what we measure angles in? What units? You got it. This weird thing called degrees. Now, I know we talk about temperature in degrees. This is a different version. It's just some, units to talk about how wide how open the angle is. Now, again, I'm going to count on your prior knowledge. I've drawn a big yellow circle. I'm going to refer back to this screen several times throughout the year because I think you know, and when I draw this line across it, it's going to add it's going to remind you of a concept I'm going to come back to and back to and back to over and over throughout the year. How many degrees are in a circle? All right. I haven't taught you anything about circles and very little about degrees. How many degrees in a circle? I think a lot of people know it's 360. All right. Who came up with that number? Why wouldn't it be something like 100 or something like that? Well, I think, and somebody can check me if I'm wrong, probably a long time ago, they probably thought it took the Earth about 360 days to go around the sun. I'm guessing. I don't know. Again, I don't know that for sure. That sounds reasonable to me, but there's 360 degrees in a circle. Most people know that. So when Michael Jordan back in the day would do a 360 degree dunk, that means he was dribbling towards the basket. He spun and made a complete circle with his body before he dunked it. That's he did a 360, we say. All right. Now, that's important. 360 is a very important number in geometry, but it leads us to the most important number in geometry. And I might have mentioned this on the first day of school in class. You guys at home might not have heard this, but you're about to. So if there's 360 degrees in a circle, and I draw a line through the middle of the circle, breaking it into like two halves, how many degrees are above the line? All right. So a lot of you all are saying, well, if there's 360 degrees and that line goes right through the middle, I'm assuming there's 180 degrees on top and 180 degrees on the bottom. And that would be correct, and that is super important. We're going to use the number 180 very frequently in this class. So it's kind of the magic number of geometry, 180 degrees. All right. Some students ask me, what are those three dots there for, Mr. Metcalfe? That is a fancy mathematical way to say therefore, all right? The word therefore is like 9 letters long, or I think it's 9 letters long. Who wants to write all that when I can just write 3 dots like that? That means therefore. Any questions so far? If you do, send me an email. All right. 180, very important. Okay, using a protractor to measure angles. We decided in Indiana that's, I believe, a 5th grade standard now, or something you were supposed to learn in 5th grade, so we don't do that anymore in high school geometry, but we do classify them, okay? So hopefully you learned late elementary school or maybe in middle school how to measure an angle with a protractor. We're just going to go by looks a lot of times, or maybe if I tell you some numbers, go by the number value, but I'm not going to require you measure one with a protractor. There's 4 types. I like to look at a small, medium, large, and crazy, but you probably remember these 3 words from middle school when you started talking about angles. If it is a perfect L shape, all right, perfect L shape, we call it a right angle. It means it's exactly 90 degrees, not 89.9, not 90.00001. It's exactly 90 degrees. Boom. Perfect L shape. All right. That's a right angle. I call him medium. All right. He's the medium guy. We indicate that with a box in the corner. Usually red, doesn't have to be, but usually there's a box in the corner. And that, whenever you see that, that's a very important symbol we use in geometry. That means that angle is exactly 90 degrees. Then when you get smaller, so if we use an L as medium, if you get smaller, or if the alligator starts to close his mouth, anything less than 90 is what we call a little cute angle, little cute one. Aw, look how cute that angle is. So angle B has to be less than 90, or visually it has to be less than the alligator having his mouth open at an L. L is 90, anything less, yeah, even 89.9 degrees, that's acute. All the way down to, and we really don't have anything called a 0 degree angle. That would be a ray, by the way, if a 0 degree angle. And then we have obtuse. Ob means big. So anything bigger than 90. So now the alligator is opening his mouth ridiculously wide. Or if you're watching that movie King Kong, and King Kong grabs, I think it's a T-Rex he's fighting, they're fighting with each other, and he's trying to protect the lady, in the star of the movie, and he's fighting this like T-Rex on this weird island, and he grabs the T-Rex's jaws, and then he rips them like wider open than they should be, like that, So once the alligator's jaw goes open more than an L, more, big, ob means big, greater than 90, you're now an obtuse angle, but there's a limit to it, all right? So you can be a 90.01, and you start getting bigger, you're obtuse all the way, but stopping before you get to 180 degrees, all right? So 179.99999 forever is still obtuse, but when you get to 180 degrees, that comes to the last type of angle, the straight angle. And the straight angle, it's 180 degrees, and you guessed it, it's basically just a line, all right? And just to refer back, remember that big yellow circle on the other screen? And I drew a line through it, there's half of it, and we talked about there's 180 degrees. There you go. That's where that comes from. All right, so those are your 4 classifications of angles. Right, smaller than right, bigger than right, and then basically a straight line. Okay, we're going to probably let you classify a few on the next screen. Here we go. Let's see. Yep, we got this beautiful drawing. Take a few seconds to draw that. And then we'll classify some of these, and then I'll give you a chance to name some other ones. So you all are drawing that. I'll give you a few seconds to draw it. All right, welcome back. Let's classify these. The first angle is angle MJP, and if you need to, you can highlight it to see what we're talking about. MJP, remember, you follow that order when you try to make an angle. So MJP would be this angle right here. Oh, wow, that's too big. Undo that. Let's make it a lot smaller. MJP. Okay. It looks like an L. It is an L. That is a right angle. And matter of fact, you see that red box at its vertex. That's telling you absolutely it's not 89.9, it's exactly 90 degrees. So that's a right angle, all right? So he's a right angle. The second one is LJP. LJP is this guy right here. I'll highlight him in a different color, maybe pink. LJP. So that one is the alligator's mouth has opened. It was at an L shape, and now it's even opened a little bit more. I explained to you how bigger than 90, that takes you into obtuse. All right, so this one would be obtuse. And then, let's see, the last one from this section is NJP. There's NJP. Okay, I'm just going to outline it with my finger. NJP. It's this little guy right here. NJP. And I probably gave it away, the fact that he's a little guy. Definitely smaller than 90. Matter of fact, here's the 90. The alligators had to close his mouth quite a bit to match up with NJP. And therefore, he must be acute. All right. Now, somebody else from the studio audience, name another acute angle. Don't use NJP. Try to find another one. Or, as that one guy says, another one. Okay. So we use this little skinny one. I see another little skinny one right here. That's a kind of a skinny one. So I'm going to pick him. You could call him LJM or MJL, and he's not the only one. There's others, but that's one. I'll write that one down. But I said LJM, so another acute angle would be angle LJM. Notice how all my angles so far, the middle letter has been a J. Why? Because that's the vertex of every angle in this picture here. So all of them are going to have J as their middle initial, so to speak. Obtuse angle. All right. I highlighted a big, the purple one, so let's not use that one. Let's use a different one where the mouth is open wider than an L. So imagine the alligator or the T-Rex in the King Kong movie. Imagine his mouth being opened wider than 90 degrees. So I picked that one earlier. Another one you could use, look at this one. Look at KJN. All right, here's your 90 degrees. His mouth is open really wide. Matter of fact, he's getting close to being that straight angle, not quite. So that would be a good example of obtuse. So angle KJN would fit that. KJN. Any questions on acute, right, obtuse angles? Didn't talk too much about straight angles on here, but if I asked what the straight angle would be, there's just this line right here. It would be KJP, you could call it, or you could call it PJK. It's the same one. All right. Moving on. Some guided practice. You're about to have a page of guided practice, so we'll go ahead and skip past that. Congruent angles. All right, congruent. We got that word last lesson. Congruent, remember, means identical twins. Basically, they're not just equal; they're the same shape as well. So congruent angles. We've got symbols for both of these words now, so instead of writing all that out, you could write the congruent sign. An angle with an S means angles, congruent angles, and they are simply angles with the same measure. All right. Now, we indicate that on drawings. Instead of always telling you these two angles are the same, we can indicate that on drawings, kind of like the tick marks we did on segments. For angles, we put swooshes. All right. So you see this swoosh right here? That means this angle ABC, it has one swoosh in it. And you see this angle over here has one swoosh in it. Those two angles are congruent, or they have the same measure. And actually, I even indicated the measure. They're both 65 degrees. So one swoosh means those two guys are the same. You'll notice the angle next to them, this one right here, he's an acute angle. See, his mouth is open bigger than an L. And this guy over here, same thing. His mouth is open bigger than an L. Those are, they both have two swooshes, so they're the same as well. All right, so congruent angles are always well, not always, but can be indicated by swoosh marks. So when you see those aren't decorations. Those are actually important information that whoever made the problem or the diagram is letting you know, some very important information that these two angles here are the same, and then these two angles over here are the same. All right. Now they're not all four the same. All right. Because he has one swoosh and he has two swooshes, so that tells you right away that they're not the same. Okay. Not. Okay. The angle addition postulate. Here's postulate 1-8. I'm not sure what happened to postulate 1-7. It seemed like we skipped that. I remember 1-6 from the last lesson, but not 1-8. It's the angle addition postulate. And again, it's another kind of a common sense postulate. And it says if you have a point B is in the interior of an angle AOC, so here's AOC, it's the big angle of this diagram. You put a point B in the inside of it somewhere, then if you draw a ray out to it, now you have literally broken the big angle AOC into two smaller angles. What this postulate is saying is the two smaller angles AOB plus the other small angle BOC, I love their music, equals the original angle AOC. So this piece of an angle plus this piece of an angle added together equals the whole angle. And some of y'all are sitting at home saying, of course, Mr. Metcalfe, that's common sense. But we need postulates like this for things we may do later in the year called proofs. All right. Moving on. Oh, we're almost done, guys. Hang in there. So now we're going to have you do a couple of questions. So at this point, I would pause, stand out of the way so I'm not blocking, and you all would draw that beautiful picture, label it accordingly, and they want us to find two things. And I have a feeling just by looking at this, they want these two angles, but let's read the directions. Oh, another notation that's going to be used throughout the year. You see the angle symbol, so we're talking about angle RQS. Then this little M in front of it. Whenever there's a little M in front of an angle symbol, that means what's the measure of angle RQS? That's what they're asking here. Measure of angle RQS equals blank. Measure of angle TQS equals blank. And we're going to figure those things out. So hopefully everybody's had time to draw it, pause if necessary. I'm going to jump in, and here we go. How would you do this? Well, there's something very important up here in the directions. They tell us that the measure of angle RQT is 155. So let's see, RQT, let's highlight that. So we know what we're talking about. I like to highlight things in yellow, but you know, it might have been hard to see. So let's do that. RQT, that's the overall angle. So RQT, that guy right there is 155. So I'm going to put that on my drawing. So from here all the way over to there is 155 degrees. How did you know that, Mr. Metcalfe? They told me. They told me in the directions. That's 155 degrees. So using the postulate we just learned on the previous page, if you break a big angle into two parts, not necessarily equal parts, they could be, we don't know yet, but if you break it into two parts, the two parts added together should equal the whole thing. So I'm going to say 4x minus 20. Let's see. And I don't have much workspace here, do I? I'm going to say 4x minus 20, this angle, plus this angle, which is 3x plus 14, equals the entire thing, which they told me in the directions is $1.55. Sorry, I'm kind of going off the page there. Now, I've been explaining how to solve these equations kind of slowly just to get that back in your head and how to solve equations. I'm going to go faster now because it's taken a long time. This is the geometry part. If you understand that, you understand the geometry part. The rest of this is now Algebra 1, so hopefully you can solve these. Again, I'll just real quickly say, hey, the x's are both on the left-hand side of the equal sign, so it's not a school bully situation. It's a combined like terms. 4x and 3x, that's going to be 7x. A negative 20 and a positive 14. Think about that for a second. That's might be a little tricky. This says, looks like maybe Mr. Cox loaned me a $20 bill yesterday, so I owe him $20. In my hand, positive numbers, in my hand I have 14 of those dollars still. So I see Mr. Cox in the hallway. I say, oh, hey, thanks for letting me borrow $20 yesterday, and I hand him 14 back. He does a little quick mental calculation, and he says, well, Mr. Metcalfe, you still owe me $6, and that should still come out to be $155. All right. So now I've taken this kind of complex-looking multi-step equation. I broke it down into a two-step. I'm going to go after the minus 6. I'm going to add 6 and add 6. That cancels out. You get 7x equals $1.61. And then the last thing to do is get rid of that times 7. So I divide by 7, and Mr. Metcalfe's freestyling again. 7 goes into 161. Well, I think everybody in here knows 7 goes into 16 twice. That would be 14, right? 7 times 2 would be 14, so that would take 2 left over. And then 7 goes into 21 exactly 3 times. So that means x is 23. Jordan! And is that the answer to the problem? Should I circle it and move on? No. The answer to the problem is, what's the measure of RQS and the measure of TQS? So this x is very important, but it's not the answer to the problem. So what I'm going to do to find RQS is I'm going to take 23, Jordan, and put it right here. All right? So no, it's no longer 4x. Now it's 4 times 23. Oh my goodness, my pen is out of calibration again. All right, I'm sorry. 4 times 23 minus 20. Oh, wow, it's really out of calibration. I'm sorry, guys, I'm going to have to do this again. So I'll do it quickly to not take up too much of your time and not have to pause. Okay, so I've got 4 times 23, Jordan, minus 20. Well, that would be 92. Oh, my God. I'm sorry, 92. All right, it's 92 minus 20, and that would be 72. Okay, so this angle is 72, and I'm a good 2 inches out of calibration. All right, 72 for this one. I'm going to take x, and I'm also going to put it right here. So 3 times that, 23, Jordan, would be 69. And, sorry. This is ridiculous. 3 times that would be 69, plus the 14 would be, let's see, 69, 79, 83. So this angle should be 83, and I believe this one was 72, I think. And let's add those together because we should come out to be 155. And 2 and 3 make 5, definitely. And 7 and 8 make 15, so it is 155. So this angle on the left is 72 degrees, the angle on the right is 83 degrees, and that should be that one. Ooh, we're almost done. I see a stop sign down here in the bottom corner, if y'all can see that. So I'm going to pause and give you all a chance to do exactly what we just did, and I'll come back here in a second and ask for the measure of DEC, which is a really big angle here over on the left, and then probably CEF, that's the little one on the right, and we'll be done. So hit pause. Welcome back. Actually, I gotta clear some workspace, don't I? A lot of sloppy writing. Let's see, let's get all this stuff out of the way. Hopefully everybody has that written down. And give us a nice workspace here. And I noticed something a little different. Some of y'all are saying, Mr. Metcalfe, I couldn't do this problem because in the previous problem that you did with us, you told us that the big angle is 155. You didn't tell us what the big angle is in this one. Oh, but yes, I did. Look at this vocab word right here. Oh my goodness, I just erased the vocab word. Look at this vocab word right here. Straight angle. And I'm going to calibration again. It says angle DEF. DEF, it looks like a straight line. It's telling you it's a straight angle, so that is 180 degrees. All right, so those two together, you should have made them add up to 180. Like in this one, these two together should have added up to 155. So sometimes they might do that, or they might throw this thing in there. They might say an angle is a right angle. You need to know that means it adds up to 90 exactly. Straight angles, exactly 180. Now, they can't say acute or obtuse because that's too wide of a range, but those two you need to know. So hopefully everybody used that and you didn't just put your pencil down and wait. Everybody knew that that meant 180. And I'm sorry, guys. This is, yeah. Okay, so hopefully everybody said, all right, this angle on the left plus the angle on the right should add up to 180. So you would have said 11x minus 12 plus 2x plus 10, since it is a straight angle, should equal 180. And this is a combined like terms problem because all the variables over here on the left-hand side, 11x and 2x, that makes 13x, negative 12, and positive 10. Okay. That, again, that's like me owing Miss Cook $12, but I have $10 in my hand, so I can almost pay her off, right? She loaned me 12 the other day. I still got 10 of it, so I give her 10. She subtracts that from what I owe her, and she says, Mr. Metcalfe, you still owe me $2, and it equals 180. All right, so now I just got a two-stepper. I'm going to get rid of the minus 2. I'm going to go plus 2 and plus 2. Oh, my goodness, my numbers are getting pretty big. I should have brought a calculator. No, I shouldn't. I can do this. You can too. 13x equals 182. All right? So some of y'all are saying, oh, my goodness, you think I can divide 182 by 13 without a calculator? Yes, I do. Watch this. Divide by 13. Divide by 13. Over here, the 13s cancel out. So x equals 182 divided by 13. Well, the easy part is that 13 will go into 18 only once. All right? I think everybody knows that. 13 will go into 18 just one time. There would be 5 left over. So I strike that out and I put a 5 right there. Now, how many times will 13 go into 52? Well, if you're a card player, you know 13 goes into 52 4 times. Clubs, hearts, spades, diamonds. Boom! All right? So that would be 14. Am I done? Absolutely not. I just found out what x equals. They want to know what measure of DCE is, so I put a 14 right there. And they also want to know what the measure of CEF is, so I put a 14 right there. And this one, 11 times 14. You're going to do that without a calculator, Mr. Metcalfe? I am. Because everybody in here knows what 10 times 14 is. 10 times 14 is just 140. Since this is 11 times 14, I just need one more 14 on top of that. So 140 plus another 14 would be what? 154. Take away 12 would knock it down to a 142. And man, I'm hoping I'm not making any mistakes because I'm a little bit flustered with the out of calibration, and I apologize for that. Okay, so 142. Now, I'm going to do the other angle, and since this is a straight angle, these two numbers need to add up to 180. So I'm probably have an idea what this angle needs to be. But 2 times 14, I think everybody knows that's 28. Plus 10 just jumps it up to 38. And if I did this correctly, 142 and 38 should add up to 180, and it does. So I got it correct. And we're going to stop right there. You should have an assignment loaded up right next to it. Guys, real quick, there was some confusion with the B-Day people. The virtual B-Day people are saying, hey, you're not posting any assignments on B day. It doesn't matter when I post assignments. You do them all. The A day people do them all. The B day people, you do them all. They're all geometry assignments. It does not matter when I post them. Matter of fact, I will almost always post them on A days. So just because I'm not posting something on a B day doesn't mean you don't have to do anything. You just have to go to that, go a little farther up in the stream and find the assignment, and you do it as well. So A people, B people, you all do all the assignments, okay? No confusion. All right, see you next time.